Hello and Assalamu alaikum everyone. So this is Salman from 3danchor.com and today we're going to discuss introduction to 3D designing and modeling using SolidWorks Professional. So if you are wondering how to develop this, this and this, for that we'll be discussing how to create 3D designs using a particular software known as SolidWorks Professional. Yes, it is pertinent to note that there are multiple softwares for which we can do 3D designing. Let's suppose there is Blender, SketchUp, 3ds Max, and various such softwares which are currently used in the market for 3D designing. But for this particular course, we'll be discussing SolidWorks Professional, and today I'll teach you all how to do 2D drafting, 3D modeling, and photorealistic rendering. So basically, there are three parts of this course, and then without further ado, let's get started.
So in this part 1, we'll learn how do we use SolidWorks to develop 2D design and then translate those 2D designs into 3D models and then towards 3D photorealistic rendering. So in this section, we'll discuss 2D drafting, then the other section we'll discuss 3D modeling, and the last section we'll discuss how to develop photorealistic rendering. In this particular course, we'll only be discussing how to develop photo rendering and not the video rendering. Video rendering is an advanced course which will be discussed later on this entire process. So now this is the screen which you see as you open SolidWorks Professional. Now moving on to Sketch. Now clicking File, New. Now we see these three options. Assembly is an advanced stuff. SolidWorks drawing is an advanced stuff. Currently, we'll be doing only part mode. So click OK. Now, as you can see that this is our empty environment, but in this particular empty environment, this is a 3D environment. As you can see on the left corner or the left bottom view that we have a history bar. In this history bar, we have front plane, top plane, and right plane. So these three planes develop a 3D environment. Now, in order to start 2D sketching, first we need to select a particular plane. For this particular example, we'll be using top plane. So how to make a sketch on the top plane is by clicking top plane, clicking sketch, or by clicking top plane and clicking sketch over here in the sketch tab. Okay. Now, what we'll be discussing are these 9 tools. These 9 tools are basically the tools which we need to use to develop any 2D model. The other tools, trim tool, convert tool, offset tool, mirror tool, and linear sketch pattern tool are advanced tools which we'll be discussing in this particular course briefly. Now, starting off with line. So, as you select the line feature, whenever you click anywhere in the screen, you will be seeing a connected line. So we have developed 5 connecting lines. Now, let's develop a box. Now, as you see that this box is highlighted. So why is it highlighted? Highlighted box means this is a closed feature. Closed features can be used to develop a 3D object. So this particular box can be easily used to convert into 3D. Any closed surface can be converted into a 3D object. Now, let's suppose if I want to use this sketch. Now, I have two options. Either I close by clicking this point and this point, or Control Z, we develop another line. So as you can see, this is a close feature again. Now, moving this box to the center, now we learn smart dimensions. So using smart dimensions, you can give sizes to any of the sides. Like let's suppose this side 50, this side 50. So this is a square. Now, how about 75 by 50 or maybe 100 by 50? So now we have a rectangle. And now to exit from this smart dimension feature, either click here or click right click and click select. Now looking at the circle feature. So we have a circle. Let's give size to it. 100 mm. Now, let's suppose I want this circle to be 200 mm apart from center to this edge. Now it's 200 mm apart. How about 100 mm apart from this edge? Okay, as you can see that this circle has turned into black. So black always means a fully defined sketch. Any sketch which is not defined will turn into blue. Now, if I want to turn this sketch as fully defined, first I will give dimensions to every other side and then from the origin. As you can see now, the box is fully defined. Exit sketch. So I'll rename this to sketch 1 and then top plane, hitting sketch. Now, the third feature, spline. Spline is basically a multi-point curve. Right click, select. Now, to convert into a closed surface or a closed object, we connect the two dots. Okay, so this is spline. Now, rectangle. How about a center rectangle? Or maybe a 3-point rectangle? Or maybe a parallelogram? Okay, exit sketch. So, again, top plane, arc. Using line. and voila. So exit sketch. Now top plane sketch again, oval. Similarly, slot. Now just remember, in every other shape, if you want, we can give dimensions. 75, 50. To fully define the sketch, like let's suppose 340 mm by 135 mm. Yes. So now this slot is fully defined. As you can see, this slot is in black. This oval or these ovals are in blue. Exit sketch. Top plane, polygon. So pentagon. How about a hexagon or maybe an octagon? So let's leave this to a pentagon and develop another shape. Hexagon. Now we have a pentagon and a hexagon. Similarly, if I want to give a size to it, inscribed hexagon, inscribed pentagon, exit sketch, and top plane sketch, fillet and chamfer. We develop these two rectangles. First we see fillet. Fillet is basically cornering any sharp edge. So 10 mm, okay. This, and this. Done. Or maybe chamfer 10 mm, it's okay. This, and not these. So let's say I want to do only these two corners. Okay. And now I want to do all the corners. Exit sketch. Again, top view. Let's see what this trim feature is. So what this trim feature does is we can remove any excess edges. Like let's suppose if I want to convert this particular sketch into a closed scalene triangle. Yeah, trim entities. Now click and drag this, and this. As you can see, this is highlighted, which means this is a closed surface now. Okay. Similarly, what's offset? Let's suppose this is a circle. I want to develop a cylinder. Offset 10 mm outside or maybe 10 mm inside. Reverse. Cylinder. So this was offset. Mirror. I develop this line from the center or maybe the origin. Select this line. Make this a construction line. And now let's use this mirror. Mirror entities, this and this, about this construction line. Voila. So this is mirror 2. Okay. So now we'll see linear sketch. So in a new sketch, suppose this circle, sketch, select this particular sketch, 50 mm apart, 5. Similarly, in the vertical direction as well, 3, 50. Okay, this is a linear pattern. Now, last, move and copy. Let's suppose I want to move this circle. Move from and to, starting point, this, and here. Click, tick. Similarly, copy. Starting point, this, and so copy, copy, copy. Let's, since rotate won't work in a circle, let's try scale. Scale this entity by 2 times. Okay. So by reference of this center, scale by 2. Let's go 1.5. Exit sketch. So these are basically 2D sketch features. Now stay tuned for part 2 where we'll discuss how to develop these particular sketches into 3D. Now in this part 2, we'll see how do we turn these particular objects into 3D model. Now before that, let me show you how this history bar works. Now let's suppose this sketch. I want to change sizes in this sketch. What I'll do is just click on sketch 4, edit sketch. Let's suppose 75 by 100, 350. Exit. And the size is updated without changing any other feature. So these are basically the small functions of our 3D design software, specifically SolidWorks, where we have such precise measurements and changes available. Now, moving on to 3D modeling. So sketching is basically for 2D sketching. Now we'll change the tab to features. Features is basically 3D modeling. Now let's suppose starting with sketch 1. This is sketch. Now I want to convert this into 3D. How about starting with extrude? Okay. Now I can pull it from here or maybe entering a precise size, 250. Similarly, maybe 200. Similarly, maybe 300. Similarly, maybe 150. Similarly, maybe 375. Similarly, 350. Now, as you can see, this was an offset circle. So it has developed a hollow cylinder. Similarly, and similarly, so is these are 3D objects developed from our sketched 2D model. This is called extrude command. So let's hide all these bodies, hide, and let's see other features. Like let's suppose I draw a line on the top sketch, and then on the right, I develop another sketch, a circle. Or let's suppose a trapezoid. Now we have learned extrude feature. Now we are learning sweep feature. Closed surface, this one, a curve, this one. Okay, so now our object has been swept. In right, now I want something as loft. So I want to develop another plane. Let's suppose 150 mm apart. On this plane, I develop sketch circle. Mm, so this one. Now let's use loft. So close feature this and this. So this is loft. Now let's suppose I want this feature to be not 100 but 500 or maybe 250 mm apart. So it is revised. So this is a feature of history bar. So I hide this plane. Now sweep, loft. Now let's learn revolve. So I hide this as well. Top plane. Okay. So Center line. Sketch. Wall. Selected contours. This one. So revolve. Now let's hide this and see. Extrude done, revolve done, sweep done, lofted done. And similarly for extrude, cut, plane, sketch, again top plane, center rectangle. Now, if I extrude this by, let's suppose, 50 mm on the bottom side, or maybe 100 mm, 150, we have extrude. But since we are learning extrude cut, using this sketch, performing extrude cut. So if I do 200 mm, it will be a through cut. But if I'll do 50, it would create a hole inside, small box. So we are done with extrude cut. Similar is the revolve cut. And now let's learn about fillet. Mm, let's unhide one of our sketch, fillet. Just like in the 2D sketch, in 3D sketch, fillet commands works the same. So these two edges have been curved or maybe filleted. Similarly, how about curving the inner edges? Done. So this is how we use fillet. Now, why not chamfer? Similarly, if I want to make an edge or maybe what do you call it? A cut corner on this side. Why? 10, maybe 60-degree angle. Flip direction. Okay, and you have it. So we have learned fillet, we have learned chamfer, lofted cut, swept cut, and revolved cut works the same way as extrude. So similarly, talking about linear pattern, the direction, let's suppose direction is right plane, bodies to pattern, this one. I need 4 bodies at 250 mm apart. Oh no, it was 1000. Oh, or 5. Here you have it, a linear pattern. And now, how the shell command works. Shell command, in shell command, we select a face and then we give a size. Let's suppose 2 mm. So if I hit this face and click 2 mm, then this face would be removed and the inner sides will be 2 mm thick. Now, if I select this face as well, then I can see a hole. So in shell, it removes all those sides or all those faces basically which have been selected and give it a thickness. Now, right plane and let's check mirror. Bodies to mirror, maybe this one and this one, above right plane. Let's suppose this one as well. So a mirror. Hiding all of these, clicking the hide, and hiding all of these, giving some color. Hmm, Now going to appearance manager, click red, this one, this one, this one, this one, this one, this one, this one are to be red, gray. So we have given a color. So this was about it for the 3D modeling section, and now I will lead to the photorealistic rendering section. So now in this last section, we'll discuss how to do photorealistic rendering, and also we'll develop a small vase just to show how do we use these 3D design softwares to model our requirement. So now starting with photorealistic rendering, like we have features and sketch, we also have SolidWorks adding and then photo view. You will see in a while that we have render over this tab, render tools. So now clicking preview window. If you want to turn on perspective like recommended, changing the perspective, modify 0.5. Let's suppose if you want to do that, then again preview. It takes some time. And then you can see the photorealistic view of these shapes. And there you have it. Now let's suppose if I want to change the color green to orange and change. So this is basically an integrated preview. So using the snipping tool or maybe the save tool, we can save this particular image if we want to. Similarly, if we click final render, then this picture or maybe this view would be final rendered. And then you can save it from there as well, from the save menu. So this was about it for the photorealistic rendering section. And now we'll develop a vase. View. So while we are developing this, it is pertinent to note that SolidWorks is basically mostly for still life 3D modeling. Let's say this is around 25, 37. Okay. Okay. Maybe 75. Okay. Now we'll let this edge 5. No. 10 offset 2 mm. Close these sides. Now I develop a construction line. Now, as you can see that this is a quarter section of the vase. Feature, wall, and we have a vase ready. Perspective, maybe. Okay. Now integrated render again. Now we wait. and it's ready. Even if you want to see the cross section, it's there. So it's a vase. So this is from my side in the 3D photorealistic rendering, and I'll see you in the next one.
So, like in the last video, how we created a vase, this is just an example of how powerful a 3D design software is that can not just give a visual appeal to your particular design, but also can be used for product manufacturing. You can easily use these files to 3D print this particular design and can also share these particular files to the manufacturer to develop this product in real life. So this is about it. This is Salman Heather from 3danchor.com. Stay tuned for more videos. Thank you. Assalamu alaikum.